Hello, I'm Roman, and welcome back to the series of the videos Neural Networks from Scratch in Golang. And at one of the previous videos, somebody posted a question if there is a link to the code that I'm writing here. And I didn't post it before, but right now I created a repository on the GitHub and I kind of uploaded all the things there. This is why you already see that I have a branch and I didn't have it before. So the link to the repository will be in all the next videos of the series. Second one, I would ask you, I just want to remind that I have another channel, like the one that I started before this one, and the second channel is more like a talking head videos about all the things around tech industry, and I actually started to go a little bit beyond only like talking head videos where I only trying to share some things like my knowledge, and I'm trying to do more things there. So I would appreciate if you take a look. And regarding this one, like in the previous video, what we tried to do, I started to debug the neural network that I have, and there is a big problem with the, well, not a big problem, there is a problem with the code that when I started to actually train the model, I don't see any improvement, while the Python implementation that comes from the book that I'm using, and just want to remind that this is the book that I'm using as an inspiration. Well, not an inspiration, I'm basically studying all of the things and trying to replicate it with a Go. So, on the right side, you can see that I prepared the code, well, I took the code from the book, and in the previous video, I prepared the mock data, so right now we have the specific weights for the first layer, for the second layer, and the input data. I have the same for in Go. So basically right now, if I will start, why it takes so long? Okay, so, it's actually started to train, but where is it? Yeah, so we have the weights, and if we take a look here, we should have the same weights. For example, this is the layer 2, that's the same. Why I did this? Because right now we have two implementation, one is working, one is not. We're going to debug it, and the first thing first, not this one, right? So we're going to do it in a old-fashioned style using the printf. I mean, I can use the debugger, but to be honest, I try to debug it using the debugging UI and inspecting like big two-dimensional matrices that are actually one-dimensional in the memory. It's not that convenient, so we'll start from doing it, well, just printing the result. What I'm going to do, I'm going to have one epoch of training so we can see the results. And actually, the interesting part that it produces the same, it produces the same loss value and the accuracy. But once we go further, okay, maybe actually I need to do 2 epochs. And I'm going to comment this condition, and I will do the same here. Where is this one? So, yeah, that's the Python we're talking. Okay, so we have this and we have this. I mean, they both changing, but differently. Okay, so let me undo this and let's start from the first one. So what we're going to do, so we have the dense one. It means that we're going to print every single thing, I mean every step, and see if we actually have some strange things. We have the dense, we have the first output, same we should have here, print dense one, I think output, oh, it's lowercase everything, okay. Yeah. Yeah, the problem that I have 300 samples. Maybe I should limit it to the one, because it's like too many things to compare. I mean, it's not that easy to compare. Well, okay, first I'm going to delete this one so it won't confuse me. I will do the same here. Next, what I'm going to do next? Next, I'm going to... I have this one, but I have the results, but maybe I can slice values equals to float 64. Okay, there are 0, 0. Okay, let's take the next one. Let's take the next one, which is this. What I'm doing, I'm trying to return... I'm trying to use one sample. Well, it's declared but not used. That's because I need this. Oh, values. Maybe that's actually a sign of a problem. Where I have the parse data. I have xx equals to list list from side and its array. Reshape in 1, 2. Will it work? And interpret as data type. What? What? Okay. Okay, so we have something. And actually, it's really interesting that I have a crash on the softmax, because I should not, right? So it might be the case actually, but what we have? Okay, so I see that the first is similar. Okay, then where is it? Where is it? First is similar. Then we print in the activation 1 output, right? Which is the relu result. Which is the relu result. I'm hiding it here, but instead of the dance, I'm taking the activation 1, right? And then we're doing the same. Index out of the range. Wait. Is it correct? Okay. So yeah, the relu should... What relu should do? It should return the value if the value is bigger than 0, or 0 if it's a negative value. So from what I see, 3, 1 and a 6, and the rest is zeros. Okay. That, okay, works again. And this works, okay. Print dance to outputs. Dance to output. Here, then change dance to output. Okay. And okay. Like this. So far, so good. I mean, I'm pretty... Oh no, the second one is not the... it's not the relu activation, which means that... What it means? It means that I have a loss and I have the output. And I think this one is... This one will be not that good, right? Because it's loss activation. Okay. Clean. Sorry, loss activation. Okay. And panic index out of the range. So I'm not even... Okay. What I do at forward, let's take a look once again. So the forward takes the activation and calls forward. The forward is the activation softmax, right? So I have the same. Oops. Right? Maybe I confused it. Softmax activation function. Okay. What do we do? Let's debug it. Okay. Interesting that we're storing the inputs, but I do not store it here. Maybe because it doesn't make any sense. Okay. It tells me that at the line 25 I have a mismatch. Oh, okay. it's a call for the softmax, and so it's actually inside category cross entropy loss, not the softmax. Okay, so the softmax is actually okay, right? So let's take a look. T print the land mat or I'm taking the A activation output, right? And then I'm going to calculate in the loss. So here that should be this line, right? That should be print self-activation output. Why is it printed 2 times? Wait. Print. Okay. Okay, so the loss softmax is okay, right? That means I can remove this, and then we go into loss.calculate. And here I'm doing the same. Here I'm going to do the same. This one. Okay. Which one? Sample losses. Okay. Let's continue. I just while I'm doing all of this and I'm cooking at the same time in the oven, so I'm going and checking from time to time if it's not burning. Okay, so we're going to calculate, then we go into the forward, and inside the forward we have the problem. Okay, so where we have the loss, we have the forwards. Where is it? Okay. So this is the one. This is the one I have the problem right now. Let's... Oh, and this is the one where I created... Okay, which index of bound checks, loss, third prediction clipped at... Okay. Let's take a look. So we have the... I'm making the copy of the predictions, and then I'm creating the confidences, which is, okay, so here what I'm doing is I'm taking the, okay, let's debug it. Format it, and predictions flipped new. Oops. Okay. I have this and I have this. What it means? It means I have the clipped and unclipped. Okay, so this is clipped, this is not clipped. Do I have the FMT println here right now? Loss formatted. Okay. Run model. Okay. So how the confidences look like? Implement the target shape equal to. We have the target. We have this one, right? If I will remove it will work, right? Yes. I don't want to be confused. Okay, let's print just to be sure. I mean, why predict clip? Okay, that's correct. Okay, then the interesting one is this, and it's correct confidences. Oops. So this is the one. What is the shape of this? So I guess in my case the target should be print samples and print y true. Okay, so it in my case it changed only for the first one. Okay, to be fair, it means that if this one is changed, then target class is equals to int, and that's the 0, right? In that case, it should not have to crash. Yes, okay. Then okay, so this crash is just a problem of y equal to np array from 0. Okay, from 0, but okay, then we have confidences. What is it? Okay, that's the single value, and this is the single value. Okay. So far, actually, all good. Right. So, okay, negative log livelihood is an array. So, yes. So this is negative log. Surprise, surprise, it is the same. Okay, so there are two things. The first one is it all works okay on 1, or there is an issue with the backwards, which we're going to test right now. but do I have any prints? No. I have the accuracy 0, I have the loss, and I have the 0, this epoch. Okay. What it means? It means that we're going to test loss. Okay, so the loss activation output is the same, right? So we're going to test the D inputs, right? After the call. So it's print formatted loss activation D inputs. Okay, this one is correct. Okay, this one is correct. This one is correct. Then we go into the next one. We will go one by one. And well, there is always a chance that I will go over all of them and all will be good, but I will still have the different results, which will be very, very funny. They the same. Okay. And activation one, right? Well, this is interesting. Okay, so I finally got different results, but this is very, I mean, I have only this one the same, but I have should set 0, 0, 0, zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3, 4, 5, 6, 7, 8, 9, 10. But this is the good. This is good. It means that I'm onto something. And yeah, that should be the simplest. Should be the simplest thing, but really? So I'm that stupid. Okay. Okay, well, wait. So I'm taking the copy of the values, then I'm setting 0 value for all of the places where inputs is less, not the D input itself. So that should be input, not activation inputs at I and J. There is a minus sign here. Okay. Nice. Okay, so okay, let's go next. Right now they're equal, right? Then no, I will check everything. Like it's not like I'm going to dense 1 and where it's not like I'm going to leave it unchecked. I don't want to, spend the same debugging session because it makes no sense. Okay. 1 minus 5.4. Okay. So right now we're going to actually check the params. So the first one is dense 1 weights and dense 1 bias, right? We have weights and we have biases. Let's start from the biases. 0 minus 16 0 0 0. Okay. Minus 5390. Okay, very promising. Very promising. Then let's take a look at the second one. Okay, they look correct. So what I can do right now, I can dismiss. No. I can dismiss this one, data sets and loss. So this is the actual change. It works. And this is how like a single line can screw you like fully. So this is the model that actually got trained. I mean, so what I can try right now, instead of the mock data, I can try to create new one. Well, I can try to use the generate model and not the mock data, but the one that can actually yes, this is different. Okay, this mock is commented, weights commented, this is commented. So that should train. So I have the accuracy that interesting that it's going down at some point. And I have loss that is bigger and higher, and then it goes down at some point. Well, I think the loss should go down. Yes, but the accuracy is not going. But there is a change. I mean, there is real change, and yeah. So I have this. This was the error that fix. What does it actually fix? Relu backwards. Relu backwards has, and yes, use normal and then Okay. Okay, so I'm not going to use this. Well, I mean, for now I can close it and we can get back to this mode. What it means. I think I will stop for today because it's just a logical ending for this series. Oh, I can actually read the leftover in the chapter. And I think this gives us an update on where model accuracy and loss every initial we can see the consistent improvement. Yeah, they've been jumping between, like, jumping back and forth. Additionally, we have prepared the animation to visualize the training process and to convey the impact of various optimizers and their hyperparameters. The left part of the animation canvas contains dots, where a color represents each of the three classes of the data, the coordinates and features of the background colors of the model predicted areas. Ideally, the points, colors, and the background should match if the model classifies correctly. The surrounding area should also follow the data's strength, which is what we call generalization, the ability of the model to correctly predict unseen data. The colorful squares on the right, this one, show weights and biases, red for positive and the blue for negative values. The matching areas right below the dense 1 bar and next to the dense 2 bar show the updates of the optimizer performed to the layer. This one. The updates might look overly strong compared to the weights and bias, but that's because we're visually normalizing to the maximum value. The other three graphs show the loss accuracy and the current learning rate values in conjunction with the training time epochs in this case. So yeah, it's interesting, like accuracy starting to jump between back and forth. Our neural network mostly stay stuck at around loss of 1 and later. I think I have the same. This one. I think I have something like this. Well, it depends. Like this one is better, but I mean here it's not really random because once you call the nnfs.init, they override in the random seed. It's not random, so this is how every time you run the program you get the same results. I don't have the same behavior. Maybe I should, but it's incorrect. But the idea is the same, so it kind of stuck around some value. And looked, this is interesting, how it jumped and then got back. The animation also has a flashy wiggle effect, which most likely means we choose too high of the learning rate. Given that loss didn't decrease much, we can assume that this learning rate being too high also caused the model to stuck in the local minimum, which we will learn more about soon. Iterating over more epochs doesn't seem helpful at this point, which tells us that we're really stuck with our optimization. Does this mean that this is the most we can get from optimizer on this dataset? Probably not. We definitely can decrease this. Recall that we're adjusting our weights and biases by applying some fraction, in this case 1, to the gradient and subtracting from the weights and biases. This fraction is called learning rate, and this is primary adjustable parameter for optimizer to decrease loss. To gain an intuition for adjusting plain or initial setting the learning rate, we should first understand how the learning rate affects the optimizer and output of the loss function. So I'm going to save it for the next video. I will stop for today. Thank you for watching, and I see you tomorrow. Bye bye.